Hi guys and welcome to Learn Extra Live. It's a Monday, that means it's maths and grade 11s. It is finally your turn.
Yay.
I know that they were obviously watching the grade 10 show because that's what good grade 11s do.
Absolutely, I think so.
They learn more and they learn extra. How are you, Dina?
I'm well, and I'm ready for the trig graphs for today with grade 11s. We're going to make sure that you know everything that needs to know about period, range, domain, translations, horizontal, vertical, all those good things about trig graphs. So stay tuned because at the end of the lesson, you would have learned a lot extra.
That's awesome. That's exactly what I want to hear, they want to hear, and I think that's why we are all here, right, Dina? Okay, so take your spot at the board and I'll do my little thing. So what I want to tell you guys is that you need to be chatting to us on Facebook. It's facebook.com/learn extra. And the great thing about this is that you can post any questions that you're not understanding on the page. You can help other learners out, post inspiration, study tips, anything. And what this could get you guys is this awesome Casio calculator. We give one away to grade 10, a grade 11, and a grade 12. So there's a pretty good chance this could be yours today. And we are posting the winners from last week up on the page, on the Facebook page. So keep watching that. You can also chat to me on Twitter @LearnExtra. So if there's anything you need, guys, I'm here to help you out. I'm between you and Dina. And this page is not only for us, well, it's not only for me, I'm trying to say, it's for all of us. So without further ado, I want to give a big shout out to Liberty and say you guys rock. Thanks for making this show possible. And Dina, I think it's time I stop talking and you start teaching. Take it away.
Thanks so much, Indy, and it's lovely to be with you again. And as I said earlier, we're going to look at trig graphs. And I thought instead of giving you all the theory, we would just look at an example and extract all the theory that we should be able to know out of that example. And then thereafter, we'll do a couple more drawings of particular graphs with their particular features as a result of the transformations that they've undergone. But let's look on the board and let's have a look at the given example. Right, we're told that given on the picture above is the graph of f of x, and it's equal to cos x, and it passes through the turning point P, which has got coordinates a, b. So if we look carefully at this graph, it's been given a label. We've been told that it's the graph of f of x equals cos x. So it is a parent graph because it's got no coefficient of the ratio, no coefficient of the angle. It hasn't been translated up or down, and it hasn't been translated left or right. So it certainly is the parent graph. And as part of our theory, we should be able to know what are the basic features of that parent graph. And I think they're actually highlighted by the picture. So what we would have is at 0 degrees, if this was 0 degrees, we would have a maximum value of 1. Then the cos graph would travel by decreasing all the way to this value here, which would be 90 degrees, and that would have a 0 value. Your cos graph continues to decrease until it reaches this value here, which would be found at 180 degrees, and that would be its minimum value of -1. And then so it was decreasing until then, and now it picks up, it increases all the way to 270 degrees, and we then end off at a maximum of 360 degrees. So this pattern, or this cycle, that starts at 1, goes through 0, travels to -1, through 0 again, and back to 1, it will now repeat itself all the way to 450 degrees, all the way to infinity. And it will also repeat itself on this side here as it travels to -90, and it goes all the way to -360 and beyond as well. So the cyclical nature will keep on repeating itself. And for it to get from a 1 to another 1, it takes this graph 360 degrees. And that 360 degrees is what we call as the period of the graph. It is how many degrees does it take for one cycle to take place. So if we started at 0 and we went all the way to the next 0, it would take you, actually a 0 is not a very good idea, but a -1 would be from a -1 to another -1, it would be 360 degrees. The zeros are not periodic over 360 degrees. The zeros are periodic over 180 degrees because it takes 180 degrees for every zero to reappear. So the period of the cos graph of y equals cos x would then be equal to 360 degrees. Okay, so the features of the cos graph, simply at 0 we've got a 1, we go decreasing to 0, decreasing to -1, 0, 1, and so if we weren't to plot any function of the cos graph, we would plot it that way. So let's have a look at some of the features as a result of some transformations. Firstly, they would like to know what would the values of a and b equal. And if we looked at a and b, since it's the parent graph, we would now have that this is actually the minimum value. So we would have a minimum, and this minimum is happening at -1, and therefore the coordinates here would be the x value, which is your angle, so it will be 180 degrees, and the y value would be -1. So those would be the coordinates of our minimum. Further, we would like to know how would the coordinates of P change if we were now sketching the graph of g of x is equal to 2 cos x? What changes? What is the effect of having the coefficient of cos x? What happens? The next question is, what would happen if we wanted to sketch g of x, and we would now have g of x equals cos 2x. So in this case, we have the coefficient of the ratio as a changing parameter of the ratio. And over here, we have the coefficient of the angle. What will happen if you double your ratio? What will happen if you double your angle? How will that affect the graph? And then we would like to know, in fact, this one's been written as g, so let's just use the same notation. This would be an h of x is cos 2x, give the period of h. What would the period be if you have a change in the coefficient of the angle? So these two things are connected. There's some kind of thing happening here that if I change the coefficient of the angle, that something's going to happen to my period. There must be some connection between these two. And finally, we would like to look at what happens if we have this new function k of x, and k of x is the function where we have cos x minus 2. And we'd like to know what is the transformation that takes place in order to get this new graph. So some connection there. What transformation do we see? And then finally, we'd like to look at P of x as the cos of x minus 30 degrees. And again, right, and we'll stop there because this is a different function. So here, to look at the difference, we have a constant as a term with a cos function, whereas here we've got a constant as part of the angle. So there's a translation happening around the angle. Constant is inside the bracket, whereas here the constant's got nothing to do with the angle, it's just a constant attached to. So we could actually rewrite this as minus 2 plus cos x. That would be the same thing. That would be the same function. All right, so we've seen those 4 different transformations. Coefficient of the ratio, coefficient of the angle, And then if we are adding a constant to the ratio, or if we are adding a constant to the angle. So there are 4 very different looking equations. So therefore we're going to see some very different things happening on the graph. Let's go back to the graph and let's do some discussion. Right, the first one is what happens if we've got 2 cos x. Okay, well simply what we currently have is we have a y value of 1. So if you now say, let's take, for example, y equals 2 cos x, what we're saying is that if we had a 1 over here, we want to take that value of 1 and we want to double it. We want to multiply it by 2. So what's going to happen to this value is it's just going to go up. A 0 will stay the same, whereas this minus 1, if we double it, we're going to get a minus 2. Here we're going to get a 0, and if we double it, we're going to get a 1. So let's do that and see what happens. We're going to get a 2. We're still going to get a 0. We're going to come down to minus 2. We're going to go to 0, and then we're going to go back up to 2. So in the end, our graph is going to do this. Oh, got lost there. Let's just erase that a little bit. Just erase that. And we get up to there. Right, what do we see has changed? So something to do with a coefficient. We've got a doubled value of y. So it seems that that graph stretches vertically. Okay, and the distance from the maximum now to the x-axis, this distance becomes double what it was. This distance to the x-axis is double, that distance is double. So the coefficient of the ratio basically doubles the amplitude. Okay, and we can see that from the maximum to the x-axis, from the minimum to the x-axis, from the maximum to x-axis, that's all been doubled. So if you were to sketch, now we can give some predictions. If you were discussing what 3 cos x would look like, then we would multiply the 1 by 3, so it would triple that amplitude. The amplitude would now be 3, so our graph basically stretches vertically. Okay, so that's the coefficient of the ratio. Let's look at what would happen if we double the angle. So we go back to the graph, and we double 90, we would now get 180. So at 90 degrees, you're actually plotting what your 180 degree value was, which was minus 1. So at 90, you're actually plotting a negative 1. At 180, you're going to be plotting what was happening at 360. So you're actually bringing that graph almost inwards. You're stretching it, or compressing it, should I say. So that instead of getting a cycle to 360, you're going to bring everything forward, so that cycle is actually going to be over 180 degrees and not over 360 degrees. Okay, so it's becoming a little bit messy to actually draw on this one, so I'm going to draw another one just down here. So if we had the parent graph, which was that to 360, we would have your y equals cos 2x as a compressed version of this. So here we would have that much. Here we would have, actually we would have about 45 there. We'd have minus 1 there, and then we'd have a 0 there, and we'd have a 1 here. Let's just get the spacing right. So you would get something of the sort. So everything is happening a little earlier, so that you'd actually get 2 curves of this graph in the 360. So that's about the 180 degree mark. So there's one cycle to 180, and there's a second cycle to 360. So this really, what I'm seeing is that it gives me how many cycles I would actually get in that period that is usually 360 degrees. I've actually got to get 2 max to max, max to max in between 360 degrees. So if I had cos 3x, if we just make a prediction, what would happen to cos 3x? We've actually got to get 3 cycles in the 360. So we're going to get 1, and we're going to get another one, and we're going to get another one, which means that our period has changed. This yellow graph's period, if it's got 2 cycles, it will start there and it will stop there. So its cycle, or it will repeat itself, it doesn't stop there, would be 180 degrees. And in another 180 degrees, I'm going to get another cycle. So the coefficient of the angle, because it compresses the graph, it will actually always affect that period. And the period is affected, if this is 180, we could say that the parent graph has a period of 360. The new graph, or the transformation, the transformed graph, will have a period that is 180, which is really 360 divided by 2. So if we take these two values, we can see that's the period of the parent graph, that's the coefficient of the angle. So the period will change with respect to knowing the period of the parent and knowing the coefficient that you're working with. So with cos 3x, we could predict what the period is, because the period in this case would be the parent's period divided by the coefficient of x. Okay, so to go back to the question, the coefficient of the angle will affect the period. How will it do that? Is our question. It will affect it by the period of the parent graph divided by the coefficient of the angle. That's standard. If you want to work out the new period, what's the period of the parent? Divided by the coefficient. So in this case, it would be 360 divided by 2, which means it's 180. Another way of checking is to make sure that there are 2 cycles in that 360 degrees. So we just compress everything, make it happen a little earlier. Right, then what happens to the coordinates of P? Remember, P we were working with was AB. What happens to the transformation if we now adding minus 2 to cos? Well, we'll go back to the graph. Go back to the parent. What happens if I take 1 and I minus 2? I go 0 minus 1. So what was happening over here is now going to happen at negative 1. I've come down 2. What was happening there is going to go down to, what's happening there is going to go down to, etc. So this whole graph will be translated down by 2 units. That's all that happens. You go to all what we like to call, these are called our quadrant angles. Because if we work with them, we can adjust them accordingly to the transformation and be able to get the new graph. So you don't have to sit there and point plot. You just go to quadrant angles and you adjust the quadrant angles. So it's the parent graph which you lower by 2 units.
Dina,
Okay.
should we take a little
Yes,
break?
let's take a break.
Okay, guys, you can see how much Dina just loves teaching. She just carries on. And if I didn't take a break, she would probably be here until the end of the day, which I'm sure you wouldn't really mind, would you? But we all need a break, so that's what we're going to do. And we'll see you now as soon as we get back. Hi guys, and welcome back to Learn Extra Live. I hope you enjoyed your break, and grade 11s, I hope that you are ready for this awesome show. Exactly like a friend of mine on the Facebook page said, Doctor, he said, grade 11s, now is the time to work hard, because before you know it, you're going to be in grade 12 next year. Very, very wise words. Okay, we don't normally do this, and I'm probably going to make my producer very scared, but don't worry, just relax. Normally, we give away the Casio labeler only the next week, but I want to announce last week's winners of this labeler. I'm posting onto the page too, don't stress, but because of these two winners, I'm very happy to announce that Dr. Fulani and Musa Nkladi have won this awesome labeler from last week. I will put onto the page how you get into contact and how you get this awesome prize, but what I want to let you guys know is that they've been interacting on the page. They help other mindsets out. Dr. posts inspirational posts and they help each other out. Musa had 149 posts on the page and Dr. had 123. So they are chatting to us all the time, and that's why they get the very, very fancy Casio labeler. So without further ado, I'm going to hand it back to Dina so she can carry on with the lesson and we can learn more and we can learn extra. Dina, take it away.
Thanks, Indy, and congratulations to those who've won the labeler. Keep posting, you know, maybe a labeler's coming your way if you keep posting. Right, for now, let's carry on with some of the questions that you've asked. One of those being, what is the period of the cos x graph? And also, what would happen if you were sketching y equals negative 2 cos x? So let's look at those two questions. Firstly, the period of the cos x graph means that the coefficient of the angle is 1. And when the coefficient of the angle is 1, the period is always 360. So it's fixed. It's not going to change tomorrow, or it's going to decide it's going to be something else the following day. It's fixed at 360. If that coefficient of x changes to anything other than 1, then your period will be affected. For now, it's 360. How is your period affected? By taking 360 and dividing it by that coefficient. That's how the period is calculated. Now, for those that have asked about y equals negative 2 cos x, so we plotted just now 2 cos x. What would negative 2 cos x look like? You do the same thing. You would take the values of your quadrant angles, and the values of our quadrant angles are a 1, a 0, a negative 1, a 0, and a 1. So you would take those quadrant angles and you'd say, these are the quadrant angle values. What must I do? I must multiply it by negative 2. So take each of those values and multiply by negative 2. What do you get? I would get a negative 2 if I multiply by negative 2. I would get a 0, I would get a 2, I would get a 0, and I would get a negative 2. Then you go back to your quadrant angles because those haven't changed, and you plot those values. I now get a negative 2, I'm getting a 0, I'm getting a positive 2, I'm getting a 0, and I'm getting a negative 2. So my graph would look like that. It would be a reflection about the x-axis, or a reflection about the angle axis. So your amplitude does not change. Many people think that the coefficient means amplitude. That's not true. The coefficient just is there to tell us what the quadrant angle y values is doing. Your amplitude is defined as the maximum distance above the x-axis. So my amplitude is still 2, because from the x-axis all the way to my maximum value, that would be my amplitude. So my amplitude is still 2. Okay, amplitude is never negative. It's always positive. So my amplitude is still 2, but the best way to always work from is from your parent graph. That is fixed. That never changes. Utilize that information to see how do my y values change as a result of multiplying my parent value by negative 2. Well, these values will change. Those values will still be 0, so that's the graph. So any negatives will create reflections about the x-axis. So that's to answer some of the questions that you've posted. Then we were doing the transformation when all these values are going to be lowered by 2. So again, if we had to take our parent graph and we have, there's my parent, 360 degrees, that's 90, that's 180, that's 270, that's 360. And I take my x and my y values, so I take my x and my cos x values, then I would get my quadrant angles, 0, 90, 180, 270, 360. And the reason I take my quadrant angles is because depending on the domain, I will then carry on repeating the same thing. As long as I know what one section of that period's doing, then my repetitions will carry on. So I don't have to work out every single angle thereafter. Right, so my cos values are a 1, a 0, a negative 1, a 0, and a 1. if I'm now going to minus 2, from that, what's it going to look like? Well, 1 minus 2 is going to be equal to negative 1. A naught minus 2 is a minus 2. Negative 1 minus a 2 is a negative 3. And a naught minus 2 is a minus 2. And a 1 minus a 2 is a negative 1. So I'm going to be plotting there at negative 1, which is over here. Then I'm going to go down to negative 2. Then I'm going to go down to negative 3. Then back to negative 2. And where am I going? Because I'm not sticking to my graph. Let's just stick to the graph here. So we would go 90 at negative 2. 180 would be at negative 3. Then we'd go back to negative 2 and up again to negative 1. So my whole graph has translated down by 2 units. So everywhere it's translated by 2 units. Okay? So this here would be y equals cos x minus 2. If it was plus 2, you would take your y values and you would raise your quadrant angles and then just trace the points. So you don't have to sit there and point plot. You just take your quadrant values and work with those as your transformed values of that quadrant. Right, and then the last transformation that we were working with was the cos of x minus 30. What do you think the period of that graph is? So we had k of x was equal to cos of x minus 30. What is the period? Remember the golden rule, if I have 1x, then the period is going to be 360. If I have a coefficient of x, then the period will change. 1x, period always 360. Right, so my graph is still going to be doing, it's a period graph, so it's still doing that. Okay, so that's still 90, that's 180, 270, 360. So that you must memorize, you must know it very well. My cycle of cos from max all the way to max travels through a minimum, and therefore, just putting in another word, the range is going to be from 1 to minus 1. So there are no cos values here at 2. There are no cos values minus 2. It doesn't exist. The range is found that cos values are sitting between 1 and negative 1. Okay, so how does that affect the graph? Well, like all algebra graphs that you are familiar with, the moment you have an x that has got a constant attached to it, minus 30 plus 30, there will be a horizontal shift. So x minus 30 must mean that at 30 degrees, I'm going to get where the 0 is. So in place of where the 0 was, I now have that 30 degrees, because when I substitute 30 in, I get 30 minus 30 is 0, so the cos of 0 is now going to be 1. So I'm going to get a max at over here, which means that if I substitute a 90 minus 30, I'm only going to get 60. So in order for me to get this value of 0, I actually have to have 120 degrees. I've got to have it there at 120. So this one's at 30. This one's at 120. 120 minus 30 gives me the 90. So what should be happening at 90 is now happening at 120. What should be happening at 180 is now going to happen 30 degrees later. This is going to be 30 degrees later, and that's going to be 30 degrees later. So my graph is going to still go through there. It's going to go towards the minimum. It's going to go through 0 and all the way back up there. But everything has shifted 30 degrees along. So my 0, my negative 1 is now at 210. 270 plus 30 would be 300, and this one would be at 390. So my period is still 360 degrees. Very important, my period is still 360 degrees. So from max to max, I'm still getting 360 degrees. However, every single value has shifted to the right by 30 degrees. So my quadrant angles are 30 degrees later, 30 degrees later, 30 degrees later. And that's a nice way of plotting that shift, is to be able to establish where is the 0 starting. Well, the 0 would be at 30 degrees, because 30 minus 30 would give me a naught. So cos of naught is 1. So at 30, it's now giving me a 1. So if you know that, then you can take every quadrant angle and just add on 30 degrees. That's one way of doing it if you had the parent graph. Another way of doing it is if you've got 360 degrees as your period, then your quadrant angles are found every 90. Okay, so the quadrant angles are found every 90 degrees. So what you now do is you can say, let's choose orange, 30 degrees plus 90 degrees, okay, would give me 120. 120 plus 90 degrees would give me the 210. 210 plus 90 degrees and 300 plus 90 degrees. So you would start with your 0, knowing that it's 1, and then since the period is 360, my quadrant angles will be moving every 90 degrees, 90 degrees, 90 degrees, and that's how you'd plot your translation. So instead of point plotting with your calculator, we've done this without a calculator, just utilizing the parent graph and how the translation affects that parent graph. Okay, so to summarize then, we would get the y equals 2 cos x, we would get y equals cos 2x, we would get y equals cos x minus 2, and we would get y equals cos of x minus 30 degrees. Okay, so what is the period in each case? Let's write down what the period would be. Okay, cos x, 1x, period is 360. Cos 2x, coefficient of x is 2, so the period is parent divided by 2 is 180. 1x, period is 360. 1x, period is 360. Okay. And we've actually got this is in the way, so we've got, what is a transformation? Let's just summarize the transformation. So the coefficient of the ratio will affect the amplitude. The coefficient of the angle will affect the period. This will be a vertical translation, and this one will be a horizontal translation. Okay, and as we've looked at when we were sketching, you must work with the parent graph and you must work with the quadrant angles. Otherwise, it just doesn't go anywhere. Right, let's see if I can find on one of our pages. Let's see if we've got a period change. No period change. Let's see if we've got a period change here. No period change either. Okay, let's look at this one. If we're given 1 plus sine x and g of x equals cos 2x, determine the period and range of f and g. Okay, let's look at the period. What is the period of this graph? Sine 1x, so the period for sine is also 360 degrees. Remember, period is not an interval notation. It doesn't start at one place and end at the other. It's infinite, so it's one value. I find a lot of people give it in interval notation, just one value. How many degrees does it take? Just how many? One value. What is the period of this graph? It's got a coefficient of the angle, so the period of g, parent period divided by 2 is 180 degrees. Okay, that's the period. What about the range? The range of f, we need to think about it a little bit. What about the range of g? Okay, there's no translation, there's just a period change. So the range of g will always be from -1 to 1. There is no translation involved. This 1 plus sine x, there is a range involved. So I would suggest that you just plot what are the parent values for sine in its cycle. Now, we've been dealing with cos, but sine behaves in the same way, except it starts at a different place. It starts at 0 degrees 0. So it will go 0, 1, 0, negative 1, 0. And depending where you are with the angles, you will establish which part of the cycle you want. But it really is a 0, 1, 0, negative 1, 0. So from a 0 to the next repetition of an increasing value, you would have 360 degrees. So cos and sine are both periods of 360. And the range would also be for the parent graph a -1 to 1. However, can you see we are taking sine, we're adding 1 onto it. So we have to take the y values. So the best way is to say, right, what are my y values for my sine graph? So sine x would be a 0, a 1, a 0, a -1, and a 0. And that would happen at my quadrant angles, 0, quadrant angles of 90, 180, 270, and 360. Now I'm going to work out what is sine x plus 1. I'm taking that value, I'm adding 1. I'm taking that value, I'm adding 1. I'm taking that value, adding 1, adding 1, and adding 1. Okay? So my graph, what is the smallest y value? It's 0. And what is the smallest, or what is the largest y value? It's 2. So my range for this graph goes from 0 all the way to 2. Smallest value first, from 0 to 2. So when you have a vertical translation, your graph is actually affected in the range. Okay? And then obviously the second graph is to sketch the graphs of f and g for a particular domain. Now, I wouldn't suggest that you look at this domain and start there. I would suggest that you always have an overview of what this graph's shape is looking like across its period, and then go back to the domain and sketch it accordingly. Okay, so we have an f graph. This graph is the value of sine x plus 1, and we've got this graph as the cos of 2x. So that's g of x. Right, and we had a discussion around the coefficient of x, of the angle, but we didn't really discuss how we would plot it. Since we start off with a period, and the period for this graph, so let's talk about this. Let's zoom in on here. So that's cos 2x. Okay, so the period is now 180. We've established that, okay? But when we're working with the quadrant angles, we have a 90, a 180, a 270, 360. We've got 4 values that we've got to plot in that period. So the value is going to be compressed, but I still need 4 of them. So I would say that I need to plot every 180 degrees divided by 4, which means I've got to plot every 45. If I plot every 45, 45 becomes my new quadrant angle. Then 45 onto that would be 90, 45 onto that, so that I get my quadrant angles. And so my overview of this graph is that it's doing this. It's going 0 to 180, and halfway would be 90, and halfway would be 45, and halfway would be 135. And the parent graph says to me that we start at 1, we then go through to 0, we go -1, back to 0, and back to 1. So there's my little graph. So that's my overview of what's happening. I'm actually showing that I need, when I plot, I need to plot in 45s, because my graph is asking me to do that. Okay, so now that I know what that one's doing, I also know what sine is doing. I can now begin to look at what that domain looks like, and we'll do that just after the break.
See, Dina just loves teaching. I know she looks with her beady eye up at the counter and she knows it's time for a break. Okay, guys, I know that you have a lot of questions, so during the break I'm going to go through them with Dina and we'll see what we can answer. We'll definitely be taking questions in the last 15 minutes of the show. So hold tight to your seats. We'll be back now. Welcome back, Mindsetters. I hope you're enjoying the show as much as we are. We cannot believe that we actually have 15 minutes left of the show, which is ridiculous. It's absolutely ridiculous. Nolita's been chatting to me on Twitter. Lady, I'm really enjoying the conversation, and we've got so many people on the Facebook page. We are going to get to your questions in the last 5 minutes. There are quite a few. It's got Malefi, Ashworth, Colofelo. We are listening to you, and we will be getting to your questions soon enough. Big up thanks to Liberty for making the show possible. You guys rock. Without further ado, I'm going to go straight to Dina. Dina, take it away.
Yes, everybody, we left off with trying to sketch cos 2x within a given domain, and we were also looking at the graph of 1 plus sine x and how to sketch both of those on the same system of axes. So let's go back and recap. We had worked out that the period of cos 2x would be 180. So we're going to plot every 45 degrees. So we had an overview of what that's doing, which means that we're now going to repeat that. So it's going to go in 45s all the way to 360 degrees. And it's going to go, and it's going to go, etc. But now we're dealing with a domain between 180 and 360, which means I'm only going to show that portion of the graph. I'm not going to show that portion. So I'm going to start at 180, and I'm going to go 45 degrees in order to get that graph. And I'm going to do the same thing for the 1 plus sine x. So let's do the cos graph first. So we'll do the cos in green. Here's our cos 2x. And seeing that we are plotting every 45, you need to make these large enough, because in your final grade 12 exam, your work is going to be marked not by your teacher, but by somebody else. You've got to make it clear as to what you're doing. So there's my cos graph. Period is 180 degrees. And we now need to add this graph here onto that, where we've already worked out that for a 0, a 90, a 180, a 270, and a 360 would be a 1 plus that. So that should have been a 1. That should have been a 2. That should have been a 1. That should have been a 0. And that should have been a 1. So if we go from 180 to 360, we're going to be plotting a 1 at 180 degrees. Then we're going to be plotting a 0, and then we're going to be plotting a 1 over here, and it's then going to go up to 2, so it's coming from a 2, and it's going to go down there. So it's doing that, your sine graph, because it's going to go up to 2 as a maximum, and this one's also going to go up to 2, and it's going to come down, because it's been shifted up by 1 unit. So my yellow graph would be the F graph, and this graph here would be my G graph. Make sure that you've labeled it accurately as well. So if I continued with my sine curve, I would plot that at 90 it needed to be a 2, and then it's coming back to a 1, so that your sine graph is above that axis of the angle axis. Okay, so that is a type of a question that you could actually make up yourselves. We've just added 1 onto sine and said, right, let's have a look at what it looks like with cos 2x. But the most used, or the most asked questions are always, what does sine 2x look like? What does cos 3x look like? And so you could draw up your own combinations of changing the period and changing a vertical translation, and just have fun with your friends and say, okay, I challenge you to sketch these two. What do they look like? And you draw them as well, and see if you both agree. So it's one of those sections that you don't have to wait for your teacher to give you a question. You can make them up yourself as you go along. Okay, so let's just see on our other page what we have. Okay, that's a good one. I'm going to see whether you can tell me what is the period of a minus 2 sine x graph, and what is the range of, and a period and the range of both of those graphs. And this should have degrees on there. And maybe you can sketch those, and there's a domain that's given. So we could sketch, and you can sketch these. Sketch for x from minus 180 to 180. Okay, I'll leave that up there for those of you who want to try that out. So while we're doing that, while you're thinking about that, we can be answering some questions. Indy?
Okay, let's have a look here. There's a few of them. Let me have a look. Okay, this one is from Zwiabuya. Zwiabuya. I'm sorry if I'm saying your name wrong. I'm sure that I will learn it by the end of the show. I'll be saying it perfectly. So they want to know, how do I find the range and the domain? And I know a few other mindsetters have asked this, but maybe we can speed through it quick.
Okay, range and domain,
Yeah.
not range and period.
This one says range and domain.
Okay. The domain you don't have to work out because your graphs work from negative infinity to infinity degrees. So your domain is for both the parent graphs of parent graphs or any other graph would just be infinity. What happens usually is that you'll be given a domain. They'll say, please sketch for these x values. So they are chopping that domain to a prescribed set of values that you've got to work in. So the domain is not something that you work out. The domain is something that you're usually given. The range, however, remember what the definition of range is. It's all the y values that graph can have. So why not draw a picture and then determine what's my smallest y value, what's my largest y value. So to determine a range is always the question of defining that word range. So it's find the y values of each graph. So if I drew this graph over here, for example, and I said to you, that went down there, and I said that this value here was 2, and this value here was negative 2, then what is the range? The range are all the values from smallest to largest, because the graph doesn't go above those. So the range are all the y values, smallest to largest. Nothing below, nothing above. So that's how you would find the range. I would sketch it first and then just read it off the graph.
Okay, let's see what else we have here. I think that this might have been from an earlier question. Okay, this one's from Colafelo, and she asks, do we always divide 360 by the given? She says cos 2x and cos 3x.
Okay, good question. Just to recap on what is the period of cos 2x? What is the period of cos 3x? What is the period of y equals cos a half x? Okay. The question that you asked was, will we always divide by the given? Absolutely. It's the given that's important. So knowing the period of your parent graph, the period of the parent graph here would be 360 divided by, as you said, the given, which is 2. So this given over here is what you divide by. The period over here is 360. Parent graph is 360 divided by 3, which is given. So the period here is 120 degrees. And therefore, this graph, I'm going to plot every 120 divided by 4, because there's 4 quadrant angles. I'm going to plot every 30 degrees. And this one, the period, is 360 divided by a half, which would give us a period of 720. So here I'm going to be plotting every 180 degrees. I'm going to be plotting values there. So this one actually extends that graph. It doesn't compress it, it just widens it further. So yes, you always divide by the given coefficient. You don't have to change it. Good question.
Okay, so I think we've got a minute left. I don't
Good.
even know if we can get through another
yeah,
question.
let's go through another question. We'll
Should
do it
we?
quick.
Okay,
Yes.
okay. Let me have a look. Oh no, now my Facebook is being very slow now. Okay, we've got, let me see. We've done how do we find the range and domain. Okay, so Cabello says, oh no. Capello says, Indy, you're so funny when you pronounce names. That's terrible. I know. I am learning, and I am going to get better. I think Dina, I'm going to hand it over to you.
All right. We'll just finish off here.
Yeah.
We've just looked at cos a half x. What would it look like? It would do the same thing, minimum and maximum, but this minimum would now be at 360. It's always halfway, and the 0 would be at 180, and that one would be on 180 onto there, so that would be 540. So that would be my cos graph. It would just stretch horizontally, not stretch vertically. And this would be y equals cos a half x. I will leave everybody to try out what does y equals tan 2x look like? What does y equals tan a half x look like? We haven't even gone there, but it's the same process. Period of tan is 180, so if you divide by 2, now I have a period of 90 with that asymptote. Don't forget that. Enjoy sketching.
Okay, guys, that comes into our show. Thank you so much for such an awesome one. I had such a fun time. I was just laughing so much at where was this earlier. Cabello also says he's a very funny guy. Thanks to Liberty for keeping the lights on. Yeah, thanks, guys. Thank you so much, grade 11s, grade 12s. You're next. See you same time, same place next week. Bye, guys.